Hello, my name is Marissa Hunter. I'm here with Jennifer, Sarah, and Tabitha, and we're going to be presenting on machine programming. So what exactly is machine programming? Machine programming is about automating the development and maintenance of software. In other words, it's creating software to create its own software. It is where programmers are able to program a computer to learn based on data so that it can make choices on its own. Automated software and hardware can improve productivity and quality. In productivity, it makes it 1,000 times improvement over work performed today. As far as quality goes, it enhances correctness and performance in that there is no human error and that the computer is able to avoid small errors. As far as the background, the first computer was invented in 1936, and ever since then, writing software has always been complex. One study showed that software programs only have a 30% rate of success, and this is because of human error and because debugging can be very complex. Machine programming was invented in 1950, so not that long after the first computer was invented. But it was not widely used until recently. Our recent advancements are due to large amounts of data that need to be processed in a different way. Also, the advancements in algorithms and computing have made machine program more relevant today. Intel and MIT have made large strides in computer programming, as well as many other companies. As I stated previously, there's mass amounts of data and more technology. So we are able to avoid having to use programmers and instead can use the computer to program itself. While before programmers had to write machine programming code, now we are able to write programs that can write their own programs and kind of work in that circular loop so that we can use the computers to program itself.
There are many applications of machine programming that we see in our day-to-day life. For example, artificial intelligence is used a lot, and you can see it in virtual personal assistants like Siri, Alexa, and other voice-activated systems like in cars. And they use different systems like text-to-speech and voice recognition, as well as like self-driving cars that use different algorithms to determine what the safest decision to make is while driving. You see that in new advancements in like Tesla. Also in personalized advertisements, search engines like Google keep track of your searches as well as Instagram and Facebook, and they take that into account using different algorithms to give you personalized ads. Another way machine programming has been applied in our day-to-day life is in image recognition. In social media, a lot of times you'll see like tagging. It's like facial recognition, as well as in photo apps like Google Photos or Apple Photos. They it's facial recognition as well as object recognition, where they allow you to search in your photo apps for a keyword, and they will find objects, pictures with those objects in it. And search engines do the same type of thing. As well as in transportation, different navigation systems like Waze, Google Maps, Apple Maps use algorithms to find the best route for your destination. And different companies like Uber and Lyft figure out the best route as well as the best cost and the most convenient driver. And they use different algorithms to do that as well. Another one is fraud detection. For example, in a bank like Chase, they monitor your spending to see any abnormalities that can raise suspicions for possible fraud.
Okay, so some primary contributors are Geoffrey Hinton. He's known as the godfather of deep learning. He worked on artificial neural networks, and he researched the backpropagation algorithm. These brought about drastic changes in performance of the deep learning models. Another person is Michael Jordan, not the basketball player, but he researched machine learning, statistics, and deep learning. Some of what he did is part of Bayesian networks, and he made a lot of contributions in like more math side, so probabilistic, graphical methods, spectrum methods, and natural language processing. Another person who contributed to machine programming is Yann LeCun. He worked in machine learning, deep learning, computer vision, and robotics. He works at Facebook as the vice president, and he also founded Convolutional Nets. The last person on this list is David M. Bly. He researched topic models, probabilistic modeling, and approximate Bayesian inference, kind of like Geoffrey Hinton.
So different universities that have good programs for machine learning or machine programming are Carnegie Mellon, Stanford, and University of California, Berkeley. Here are some examples of the research that Carnegie Mellon has done in their program. They have PhD through minor programs. So brain image analysis is the first one. This focuses on functional magnetic resonance imaging, and it measures the blood flow in the brain and sees where it increases to determine whether or not the human is eating food, building, or doing other tasks. This classifier was 90% accurate in being able to identify exactly what the brain was doing at that specific time. The second research project here is, can computers learn how to read? This focuses more on natural language processing and being able to train the computer to understand what humans are saying. So the program has 2 tasks each day. It attempts to read tens of millions of articles and extract facts that it sees in those articles. And then it tries to improve its reading competence so it can extract more facts and features the next day. So far, it's accumulated 50 million theoretical beliefs from the web and has a high confidence in about 3 million of those beliefs. And finally, biological systems is the ability to use computers to be able to understand complex interactions and systems in biology, which is something that is usually very difficult, but can be done with high accuracy using computers. So different companies that have used machine learning. So there are many different types of machine programming. One of those is natural language processing. So the idea that we can possibly take speech to text and translate anything that we're saying into text, and then analyzing those texts using vectors to determine their similarities or different properties of that sentence. Natural language processing with Python, the NLTK, has been very helpful with this, and so has Spatie. It's really enabled people to be able to do research easily by doing part of speech tagging. Machine learning with Amazon SageMaker and Cloud AutoML. So Amazon SageMaker is focused on using machine learning training jobs to be able to upload and run on the Amazon network. And then Cloud AutoML is a program that has recently come out that is able to auto machine learn. So instead of us having to program the machine learning manually, this will try and extract different features basically on its own, which has been a very interesting development. So what is the impact of all of this? Well, the impact on software development is accuracy and efficiency. If a computer can process millions of lines of data in a day and be able to learn from that data, then it will be more efficient at being able to program, and it will be more accurate than a human instead of making a lot of maybe syntactical errors or other things like that. Hardware development, it will be able to optimize circuitry or any hardware that we might use. Stuff that may take us days or weeks to do in design can be very quick if we learn how to process data and how to design software autonomously. Impact on an industry of our choice, the medical industry. The medical industry is really on a case-by-case basis. And by being able to process tons of images and a lot of data, we're going to enable better accuracy and better statistical models for people in the medical industry.
Okay, so one of the first research papers was mine, a comparative study of state-of-the-art machine learning algorithms for predictive maintenance. So basically what this article was talking about was how they applied machine programming to predictive maintenance, which is an alternative to breakdown corrective maintenance or scheduled predictive maintenance. So basically, when do they need to fix some systems or like, equipment. So it uses data to predict when maintenance will be required, reducing costs and increasing safety. So instead of a piece of equipment breaking down and they perform maintenance on it, they'll try and maintain their equipment before it'll break down. So traditionally, this requires a lot of data in order to be accurate for deep learning. But this paper was specifically researching how they could use smaller data sets, but with feature engineering. So the study investigates how deep learning approaches to predictive maintenance perform in scarcer sensor data scenarios, compare them to simpler machine learning models with feature engineering. They went through how they applied different algorithms. They tried a couple of ones, I think including like a tree one. I don't remember the other ones. But basically in the end, the results show that machine learning can be applied to smaller data sets with simple feature engineering techniques, and it would be enough for predictive maintenance. So they don't have to collect like thousands of lines of data. They were able to use a temporal convolution network, or TCN, and it worked a lot better than long short-term memory, which I think requires a lot more data because it has more parameters.
So machine programming in cancer research. So cancer is something that is in the forefront of a lot of our minds when we think about the medical industry. Machine programming in cancer research focuses on 3 different categories: prediction of cancer susceptibility, prediction of cancer recurrence, and prediction of cancer survivability. Previous limitations on cancer research was the dependency on macro scale information, which means it's very difficult for us to obtain data when it's really based upon the patient. You know, if you ask the patient a question, somebody may respond differently than another, which makes the data have a lot of variances in it. This cancer research and machine programming enables personal predictive medicine, and it looks towards cancer prevention. And basically what it does is it looks at the different protein markers to determine whether or not you're susceptible or cancer might recur, or if you will survive cancer. So the result was 15 to 25% improved accuracy in predicting susceptibility, recurrence, and mortality, and hopefully even more as the research continues.
One of the main subjects when thinking about machine programming is self-driving cars. So I looked into a research paper on self-driving cars called The Technology, Opacity, Predictability, and Self-Driving Cars by Harry Cerdan and Mary Ann Williams. They looked into the pros and cons of self-driving cars and how machine programming has affected that. The problem they were trying to solve, or that self-driving cars itself are trying to solve, is the danger of human drivers. And the solution is self-driving cars using machine programming. And the way this works is they use data to predict and to make choices. Not only is it just routing the car, but it is making choices based on obstacles or the environment around it. In this article, the author had 2 predictions. One, that it would become more common with a considerable range of functions, so that self-driving cars would not only improve, but they would just become more common within the next 5 to 15 years. Their other prediction was that they would be less predictable than ordinary people, but that is not to say they are more dangerous. They, as of itself, are not more dangerous, and in fact reduce the likelihood of crashes or harm in a vehicle. The only problem with it is that humans can predict other humans' actions, but we cannot as well predict an automated machine's actions, and therefore it is less predictable because humans will be able to anticipate human movement while they are not able to anticipate the self-driving car's movement. Nevertheless, humans are much more likely to make errors or to be distracted while driving. So this research paper found that overall self-driving cars were safer but less predictable. They also found that the car, while being programmed by humans, is making decisions from the computer. So that is why it is less predictable, because the decisions are coming from the computer and not from humans. This is an application of machine programming as it is a computer being programmed to learn to drive on its own. It is machine programming being put into use in that it is using data to automate something that would otherwise be controlled by humans.
So this article was stating that machine learning at the service of meta-heuristics for solving combinatorial optimization problems. So heuristics are basically, it's like an algorithm that provides a shortcut to solving mathematical problems. So a meta-heuristic is basically a procedure that helps select the best heuristic for the current combinatorial problem or situation. So this paper was going into the different techniques for improving the performance of meta-heuristics. And they were integrating machine learning techniques for solving those combinatorial optimization problems and integrating machine learning into finding an algorithm to best pick the correct heuristic in a sense. And this article was basically going into the different papers and that talked about the different types of integration of machine learning techniques, as seen in the graph shown on the slide. And they use different types, some of which are like problem level integration, where machine learning is used to compose the objectives and constraints of an optimization problem, or high level, or machine learning techniques are used to make a link between the different meta-heuristics versus low level, where machine learning techniques would be used in the components itself of the meta-heuristics, like operator selections and population management. This paper was basically showing an advancement of machine learning and how it can take something like meta-heuristics and improve them and make them basically do their job better.
Here's a list of our sources that we used. Thank you for your time to listen to our presentation.